So our circuit is split up into two main portions. The top portion is our 12 to 10 volts LDO, and our bottom portion is 6 to 5 volts LDO. The one thing to note for these two LDOs is that we have designed it such that both op-amp amplifiers are taking the 12 volt operation as a supply voltage. Now let me use the 12 to 10 volts LDO to explain about the operations of the LDO. So firstly, the LDO achieves a stable output voltage via a negative feedback. So if we start from the output, from the op-amp, you will see that the negative input of the op-amp is attached to the top of this linear diode, which gives a very stable voltage of 3.3 volts. Okay, and this is achievable because of the linear diode's property of a very stable, very fixed reverse breakdown voltage. The positive input of the op-amp is taken from the potential divider, right? The middle pin of the potential divider from the output, and this potential divider is tuned such that given our output of 10 volts, the corresponding voltage over here would be 3.3, which will match the linear diode. So under such circumstances, if the voltage goes up, the potential divider will cause the positive pin to go up. Okay, this would correspondingly cause the voltage and the output of the op-amp to go up. But because this is a PMOS, this would cause the PMOS to increase its ability to block the voltage across, and therefore would cause a negative feedback that will bring the voltage back down. So this is the standard operation of LDO, and through this negative feedback loop, we are able to regulate such that we have a stable output regardless of the input. So I would like to go through to show that our simulation works. I will play the simulation, and you can see that the output voltage of the 12 to 10 volts is a stable 10 volts, and the output voltage of the 6 to 5 volts is a stable 5 volts. Performing a transient simulation for the output voltage ripple, we can see that for the 5 volt output, the voltage ripple is below 4 decimal place, and therefore the output is very stable. Correspondingly, if we take a look at the 10 volts output ripple, the voltage is also hovering within lower than 4 decimal place, and therefore it's also very stable. Okay, so this is the circuit for our LDOs. We have two separate circuits, one from 12 to 10, and this is from 6 to 5. Okay, so if you take a look at the power supply, we have two power supplies in series 6 to 6 volts. So please come over. The first power supply is here to here 6 volts, and the second power supply is here to here 6 volts. Right, so across this whole thing here is 12 volts. Now I'm going to turn it on and do a demonstration. So I turn on. Okay, so you can see that the power, the voltage across the 12 to 10 is 10 volts, and here it's 5 volts. Yep. Okay. When we take out the capacitor.
Okay.
You can see that then there is now an oscillation that is due to the control of the MOSFET. And then we can see how the capacitor helps to improve oscillation, to help condition the signal. Okay, it disappears.
Pretty and sexy.
With this design, we have then moved on to the circuit design on the circuit board. So this is the printed circuit board design in 2D. We then transformed it and placed all our components in 3D. Okay, and this is a software component. And if you looked at our physical component, this is our physical component, which mirrors the software component. Let me just take a look at the difference. Okay, so now we will proceed with the demo. Let me first go through the different voltage levels. Over here, you have your 12 volts power supply. Here you got your 6 volts power supply. And therefore, the output we'll expect is 10 volts over here across this output and 5 volts across this output.
This is our output circuit, and now we'll be testing with different loads. So this is 1k ohms. So when we switch on, we can see the input is at 6 and the output is at 5, which is our desired output. So now I'll be switching over to the 100 ohms. And with the 100 ohms, you can see that our voltage did not drop. It's still 5. And then
Now testing 10 ohm at the 5 volt output. I'll do it quickly because the resistor will fry. 5 volts.